Hello, my name is Pauline Spichela. This is a tutorial series on automatic text recognition. You are watching the first video dedicated to getting started with automatic text recognition. This video presents the entire workflow of research project using automatic text recognition, in short ATR. It gives an overview of different steps of the process and points to additional tutorials which explain these steps in further detail. A how to get started roadmap is also there to guide you through important questions that have to be considered before you start using ATR. ATR covers two fields. The first one is optical character recognition, also known as OCR, which is used to extract written text from printed documents. The second one is handwritten text recognition, or HTR, which is used to extract handwritten text from manuscripts. Both techniques use artificial intelligence and more specifically machine learning to extract text from images. The workflow of an ATR-based project consists in 6 different work steps. 1. Get images. 2. Image optimization. 3. Layout analysis. 4. Text recognition and model training. 5. Quality assurance and metrics. 6. End format and reusability. You start by preparing the scan images of your corpus. The first step is to get images of the text you want to transcribe. The second step is image optimization. To find out more about the required image quality and preparation prior to uploading, please refer to the video on this subject. When your images are ready, you upload them onto a transcription platform. In those videos, we use the French platform eScriptorium. However, the process is the same when using other platforms such as Transcribus or OCRD. Moreover, there is no difference between transcribing images of handwritten manuscript or printed text. The third step is the layout analysis. The software recognizes text zones on a page. This step is called segmentation. The image is divided into several zones corresponding to the layout of the document. Segmentation itself can be divided into 2 different steps: recognition of text zone and recognition of the line of text within the zones. Layout analysis step is essential for locating the titles, subtitles, margin, or annotations. A special video is dedicated to this task. When the zones and lines of text have been recognized, the next step is to predict the content of the text. It's important to understand that the machine does not actually read the text like the human eyes does. It actually predicts the probability of a combination of letters to appear in a specific context. The time taken by this predictions process depends on several factors, such as the number of images or the performance of your computer. Then, to predict text on a specific source, we need an ATR model. A model is a file that is trained based on pre-existing training data. It consists of several pages of transcription aligned line by line with the images. These transcriptions are made and checked manually by a person. This corrected transcription is considered as the truth, and the artificial intelligence uses it to learn to distinguish the correct sign. Model training is at the core of the ATR process. There are 2 options to train a model. Either create a new model from scratch or enhance an existing model by fine-tuning it for your own sources. First, building a model from scratch demands a substantial volume of training data, which can amount to over 100 pages of manually transcribed text, especially when your corpus is very, very diverse. It involves a significant investment in terms of time, computing resources, and technical expertise, as you will be responsible for all aspects of the training. Fine-tuning a model involves incorporating your own data into a generic ATR model, customizing this generic model to suit your specific corpus. There are several sites and repositories where you can find pre-trained models such as Zenodo or HTR United. To go further, see the video called Text Recognition and Model Training. When the model has produced a transcription, you will have to check its performance. It's the fifth step: quality assurance and metrics. In the ATR transcription, several types of error can occur, such as the addition of a sign, the deletion of a sign, and the replacement of a sign by another. The performance of a model in predicting a text is evaluated by different types of score. The most common are accuracy and character error rate. The character error rate, in short CER, compares the total number of characters of the test set, including spaces, to the addition of the number of insertions, substitutions, and deletion of characters that are required to obtain the ground truth result. Each minor transcription error is an error. This means that every missing comma, additional space, or even an uppercase letter instead of a lowercase letter are included in the CER as errors. This ratio constitutes the accuracy percentage of the model on the test set. If I have a CER around 0.2, my accuracy is of 80%. The accuracy is a good indicator of the performance of a model, but choosing the highest score is not always necessary. It depends on the desired goal. For a text edition, an accuracy rate of over 95% is required. For the provision of raw text, an accuracy rate of over 90% is sufficient, while statistical analysis can be carried out using a model offering 85% accuracy. It's important to note that these scores do not have the same significance depending on the diversity of the training corpus. The greater the diversity in the model training corpus, the more data it requires to achieve higher accuracy. However, with a diverse training corpus, the model is more likely to successfully adapt to an unknown document, even if its accuracy score may be lower than that of a model trained on a single manuscript, for example. When the transcription has been predicted by the machine and corrected by a human, the final step is to export the result from the transcription platform. There are several possible formats for this, such as plaintext or XML formats. The choice depends on the goal. What do you need the transcription for? Our video dedicated to these topics can help you choose the best format. As a last advice, start with a strategy and or roadmap. Automatic text recognition offers a wide range of possibilities. However, you need to develop a real strategy beforehand to determine whether this technique is good for your needs. We designed a roadmap to help you identify important questions about your research design, your available financial and technical means. It's also a guide you in selecting an existing model. This guide will help you adopt good scientific practices in data sharing. And now it's up to you to get started. And if you want to learn more about the next step in the ATR pipelines, watch your next video.